Okay, cool. So,
Hey
sorry.
Mitchell, how
So,
come you're using Coco?
what?
How come you're using Coco?
Oh, okay. So when I made a playground, it was okay. Here, I'll just show you. If I come up here and I do new playground, so you can choose a couple of templates, but like, so Mac OS is actually a faster playground. Mac OS has a faster processor, so I just tend to use Mac OS because it's quicker. If you're going to use iOS, it's going to be UIKit. But Mac OS relies on Cocoa, so that's just the one that I use. So if you launch it in Mac OS, you can use Cocoa, which is just a different, it's a different operating system, but it's just like UIKit for
Okay.
Mac OS. Okay, cool. Any other
All
questions?
right.
Okay, sweet. So let's start out our just basic model. So we'll make a struct, and we're gonna make a Pokemon struct. And here's the thing too, like you can always do it to Codable, but if you are not in coding, you can do just decodable as well. So like the lecture said, Codable is a combination of decodable and encodable mixed together. Going forward, you guys could probably just make everything conform to Codable. It doesn't necessarily have to like encode up to a backend or to Firebase. We can just use the decodable property involved in Codable. So inside this Pokemon JSON, there are a couple of properties. I'm going to just start with the really basic one. So we're just going to do the name first. So I'm just going to say, hey, let name be of type string, right? Because this is a string right here. That's all we're going to work with for now. I hated doing that. Okay, there we go. So we've got the name, it's a string. And then what we're going to do later is we're going to decode that information so that we can get exactly just that name out of the JSON. You guys have done this a bunch of times before, but CodingKeys is just a way to like filter through the JSON and make sure you get exactly what you specify for. So we need to make sure that name matches exactly with what we have in the JSON. Keep closing that out and that's done. There we go. Okay, so we'll come back and refer to this in a little bit. That's a little small, so I'm gonna make it bigger for you guys. Cool. So do you guys remember the required method if you want to decode something? Paul talked about it a little bit in the lecture. What's the required initializer that you have to use?
Init decode.
Yes. And so that one is going to be inside of our struct. So like structs have piecewise initializers built inside of them for free. So like when you guys make classes, you have to go back in and make an init for them. But like structs by nature don't require, like they have one built inside of them. But this is a case where when we're going to decode, we have to provide it with the decoder, basically the system that takes the JSON data and crunches it down into what we need. So we do have to put in this init method. It might not populate, so you can just kind of copy along, but it's just going to be init from decoder. And then we do pass it in the decoder. That comes from Codable. This nice, awesome protocol gives us a bunch of nice things with it, and decoder is one of them. It's going to do the job of taking JSON and turning it into Swift or a usable format that we need. So once we've got that, it does throw. And what it means by throws is just like it can fail. It can have an issue. It can have a struggle. So that whenever you see that throws, don't let it throw you. It just means it can fail. Okay, cool. So in this init, we have to return everything that is specified in our struct. So these properties up here have to be returned in the initializer. Your initializer will crash if you don't execute each non-optional property, which here we're going to make sure they're all non-optional. Okay, so we need to get our name out of here. Now, there's kind of one thing missing. We can specify a name, but, well, I guess we could probably do it without. I think we might be able to do it without. I'm going to do it just because later on you guys will see why we need this. So what we're going to do is we're going to make coding keys. The coding keys just do the work of parsing, like looking through the JSON and trying to match what you've specified as your key and what the JSON has specified as a key. And if they match together, that information can be passed. So what we're going to do is we're going to make a coding keys enum. What I generally like to do, and you guys saw this in Paul's lecture today, but I like to name my keys, my very top level key, I usually like to name it after the struct. So I'll call it like Pokemon keys. Now some people will just call it coding keys, and that's totally fine. But I like to get kind of pretty specific with it, because later on you're going to go through a decoding method and you're going to have like multiple layers of keys. And so it's going to be nice to know which layer you're going through. You'll see that here in a second. So our keys are going to be conformant to type string and to type coding key. And this is just along with Codable. Codable is built off of these two properties that look through these coding keys that you've provided and generally expect them to be strings. Because usually this top level kind of JSON information that we've got here, this key, it's a string. That it won't be like an int. Even this says like 1, but that will be an initial value of like a string.
Yeah, I had a couple questions, Mitchell.
Sure.
So, like kind of like you were talking about, you have the Pokemon keys that's of type string. That's obviously just referring to the key in itself, right? Like we're not talking about the actual properties or the types of our properties, correct?
Right. We haven't talked a whole lot about like back-end conformance and like how to build out these things, because you guys really won't learn how to do it, and you can if you want to, but we won't do it as part of the curriculum. But like this specific value here, I guess it's called a key, but this specific key here is abilities, and that's a string. So like as you move down, moves is also a string. Name is also a string. And we're not worried about what's on the right-hand side of it, like what's the value that pairs up with the key. We're just specifically worried about what is this. They're generally strings. I don't think I've ever seen them not be a string.
Yeah, that was my kind of question is like, you have that ability to change that, but I don't think if I've ever seen that. And then my second question is you have a decoder initializer. I assume you would have to do the same thing for an encoder?
Yes, for and they'll see in the afternoon project today, you guys will do encoding methods, and it's generally the reverse. It's just taking properties and sending them up. And like the lecture today didn't really talk about it, the purpose being in that the afternoon project walks you through them pretty thoroughly. So we want you to get exposed to doing the decoding method, and then the encoding method is kind of a reverse. Okay. So we might get some time to talk about it, but I definitely want you guys to get to lunch right at the top of the hour. So we'll just focus on decoder for now. Okay, cool. So first things first, I'm just going to make sure that our case name is there, just because we want this name to match our coding key exactly. At this point, these two are actually going to end up being the same thing, so the enum probably won't get used. But in the case that we wanted to change this property, it would still be able to find this if we wanted it to. So don't worry too much about this right now. We're going to get back into a key and where it's going to be useful here in a second. But let's go into the decoder and talk a little bit about containment. So if I take a look at the JSON here, this is nice because it kind of lets me have drop-down arrows. This is why I'm not using Insomnia, because this one's pretty nice. But if I look at this JSON data, we've got the key of name, and the key matches up with just one string value. So if I were to go about wanting to get just the name out of this, does someone want to walk me through how I can access that name container and then just get the Pokemon name out of it? And I might have phrased that a little silly, but you guys just did this with Paul, like the very first thing you did with Paul.
So do like a let container?
Yep, so we're gonna say let container, you can name the container whatever you want, but usually container is a good way to specify like this little spot that we're working in here. So we're gonna let container, sorry, Will, I cut you off. What were you saying?
Sorry, I'm kind of laggy.
You're good. So what we're gonna do is we are going to try to decode something. So we're gonna use this decoder that's being passed in, and this decoder comes from Codable. Remember, it's just the protocol that does the job of taking JSON and turning it into a different format for us. So we're gonna try, use that decoder, and the decoder is gonna go into the container, and the container key is the very top level key that we're going to specify. So if we wanted moves, the top level key would have to be called moves. We'd have to make an enum for that. If we wanted to access the sprites, the top level key would have to be sprites. So if I'm trying to get just the name out of this, what do I need to implement for my top level key set? Think of it like a ring of keys.
You're talking about
Pokemon
just
keys.
Yep. Pokemon keys dot self. And what I really like to think of this as is this is a key ring, and it may just have one key. You might just have one house key, and that's fine. Or you might have the keys to a building that have multiple doors, and we're going to have several keys inside of them. So that's why we specify here which set of keys do we want to use. And then once we have the specific set of keys, we can go and access the exact key that we want. So you'll see that here right in a second. I'm going to say our name, and this name comes from right here, right? We're going to initialize this name finally. Our name is equal to, we're going to go ahead and try the container. And inside the container, we're going to attempt to decode a what? What are we going to try to decode from this?
A string.
A string. Yep. And we have to just specify like a reflective type. So this is just going to be a string of self. Don't let that confuse you. This is another thing we've talked about a little bit before, but we're just referring to the exact type of the thing we're trying to get out. And then what's the key that we're trying to match it up with?
Name.
.name. Perfect. So from like a bird's eye view of this, this is what's really happening is we've got a model object. And inside the model object, I can have as many properties as I want. Right now, we're just going to start with one to be simple. So I'm going to say, okay, I want to open this door to a name. Now, in order to access the door, to get inside the door, I need to be provided with at least a key, right? Like give me a key ring and have X amount of keys on it. In this case, we're only trying to get through one door, so we just need one key. And so now that we come in and we have that key, we have to specify, okay, do we have the right door? Are we in the right place? That's what this container is doing right here. This container is saying, I need to check that I have the right door. So let's go ahead and try to get into this right door with this key ring. And then if it is the right door, and we open it up and it has a Pokemon name inside, I want our name to become that Pokemon name. So don't let this confuse you. You guys have done this on multiple occasions in different ways. This is just another way to parse JSON. This is kind of like a more advanced way to parse JSON. So let's go ahead and test this out now. If we have everything working correctly, I'm going to give it a base URL to work with. It's going to be a string. And if you guys don't type this out perfectly, I think I'm actually just going to copy this. I have it in a different, yeah. I'm just going to copy this. And then I will send this to you guys in the channel as well. So that's our base URL. Sorry, I just send that out as a string and not like code. We've got our base URL. And then what we need to do out of base URL is we can send the request like a network query, but we're going to need to like, sorry, my throat's a little messy, but we need to get some data back from it. We're going to say data equals, we're going to try and get the data contents. Whoops. That should have pre-populated in it, didn't it? Come on. That should run. Yeah, there we go. So what we're doing here is we're saying, okay, I'm going to make a network request, and you're going to try and get data out of it from this network request. And I'll tell you guys in a bit, this is like for practice and for testing, this is great, but for real life code, we'll never do this. This is just for example, like to stay in a playground and not have to build an app. It saves you guys some time. This isn't like best practice. But so then we're going to say, whatever we're going to get out of this data, we're going to turn into a Pokemon. We're going to say try, and I'll just make a JSON decoder because I haven't yet. Just initialize a JSON decoder. And then every decoder has a decode property. We've actually used it up here. So we can decode something of a type and from data. So we're going to decode from our data up here. And then our Pokemon, we want to be of type Pokemon. So I'm just going to do Pokemon.self. And then the last thing that I'm going to do is I'm just going to print out, I'm going to print out our Pokemon that comes back. So I just set up this one to be the 4th Pokemon in the Pokedex. It's like we could literally do anything. We could do Pokemon 115 and something will come back for you. So if all goes well, and you guys have seen me preach this a number of times, those of you who have like come to my after hours and stuff, start small. Like when you're parsing JSON, make sure that like one thing works before you try to parse like 15 things. Because if you can parse one thing, it's gonna be that much easier to parse another. But if you try to set up 5 things to be parsed out and conform to your model and it doesn't work, you're gonna not know where you went wrong. So start small. So if we did everything right and we started small correctly, we should get a name because we've given it a key. You know, we've given the key ring and we've hopefully specified the right place where it lives. And then we can set this initializing value of name to whatever we get when the door is opened up. So if I hit run, playgrounds do take a little bit more time than your simulator will sometimes, but cool. So we did get a Pokemon back. We got a Kangaskhan. You could put in whatever you want. That's probably not that many. I know that there aren't that many Pokemon because I'm a nerd. But you could type in anything, and now you can see any network request we make varying with this base URL, we can get a Pokemon back here. And some of them might probably look gibberish to you guys, but we're definitely getting Pokemon information. We're decoding a Pokemon back from this, which is great. Okay, so now that we're getting information back here, does anyone have questions about what we did to access this first property?
So do you need the decode in order to use coding key, the init thing?
Well, so the nice thing about this is like this decoder.container finds a specific name that you've specified here. It's like you can, and that's why we use enums, right? It's because we want to limit what can be used. So like in a lot of cases, you might have user input where, do you guys remember when we made that recipes project and there was a chance for the user to like enter in a cuisine, but we used an enum to say like Thai, Mexican, Japanese, Chinese. Do you guys remember that if you were there for it? We just use enums to limit what can be used. So in this case, we just specified name because we want it to be exactly like this. Because if I specify name like this, it's going to be wrong. So the nice thing about these properties that come with Codable is that we can get very, very specific, and it has properties inside that use it, right? So like this container.decode method is cool because it says, hey, give me the type that you expect and tell me the name, and I will go look for it based off of what you've specified. So it does the work of going back into the JSON and saying like, okay, I'm looking for a string under name. And so it finds name, and then it checks for the string that's there. Does that kind of answer your question, William?
Yeah, so you're kind of like decoding in your model here rather than doing it elsewhere that we used to do it, right?
Exactly, yeah. So this is a great way to like solidify the work. It follows MVC. It gets, the work of your model is done here. The work of your view is done separately so that you don't have to kind of cross-functionally use these things. You can get your model work done within your model file this way, which is really nice. We're not going to do this specifically. When you make your network request, you're going to compile the information, get back into a Pokemon or whatever we're going to, whatever JSON we're using. So this isn't great practice for apps, but like for this case scenario, this is the fastest way to do it for us here. Let's do one more really quick. We've worked with abilities before, so I'm going to use this one just as a reference. And you guys kind of got some practice doing this earlier. So if I were to go about wanting to add abilities to this Pokemon as well, what should I start to do to refactor this? I guess first thing is to look definitely at the JSON a little bit more.
Could create another struct to represent the abilities dictionary.
We won't make another struct. We'll use this Pokemon struct inside of it. This is the beauty of coding keys, is that we don't have to make like multi-structs.
Yeah.
what we'll do instead is we're going to say let abilities, we'll make a new property for it, be of type string. Because you guys are right, before, when I showed you guys a little bit how to parse JSON, we called it abilities, and then we made an ability struct lower level than this. But like that can get pretty dicey if you keep making more and more structs. So you'll see the beauty of coding keys here. So now what we're going to do instead is we're going to kind of parse through this JSON this way, and you'll see how it works a little bit quicker. So we're going to say let abilities be of type array of string. And then this case, this key ring that we give it, the key that lives on this key ring of Pokemon keys, needs to match the JSON exactly. So we're going to say case abilities. And then if I can look here, this is going to give us an array back. This is what this is signifying. This is going to give us an array of all of these properties, which inside this, it's actually going to give us an array of dictionaries. So it gets a little bit messy. It's a little bit messier than just trying to get the name out. So we saw this a little bit in Paul's lecture, but how would you go about trying to get an array now? How are we going to do this in the decoder method?
Use like compact map.
Yeah, I'm going to start really simple for you guys because the compact map, I'm thinking about doing an after hours where we talk about map, sort, filter, reduce later, because I just don't want that to be like a huge pileup of things to learn today. We're going to do like the simple, do you guys remember the while loop method that he did? Where he cycled through? Let's use that instead, because we know that we're going to get multiple items out of this, so let's go and just try to loop through those items. So what I'm going to do here is I'm going to make a new container, because this top level container, this container that we've made here, has everything. It's all of this JSON information. Like it can be all of this JSON information if we want it to be. But now we want to go a level deeper because this is an array. So now instead of wanting all this JSON data, I want specifically this container here. I want to move a level lower to get this, and I can open these up and you guys will see what's in them, but like I want these abilities that are inside this. So what I'm going to do here is I'm going to say, I'm going to make an abilities container. We're going to do the same thing, just a little bit differently. But what we're going to do is we're going to do try, and I'm going to try to access this first container. So try container. And then once we get inside of this container, there's a couple of properties that we can use. There is a nested and an unnested, or I'm sorry, a nested and an unkeyed container. So I guess from a simple standpoint, the way that I would differentiate these two is that nested unkeyed means that there is not a name to jump into, and nested container means there is a key. So if we look at the JSON, this doesn't have a name, this specific array that we're getting back, it's just an open array. So what I'm going to do is I'm going to use an unkeyed container. And what I'm looking for is just the abilities. So what's happening here is we're looking at this whole container that we've made. And now we've told it to say, hey, find a container that matches the key abilities and get inside that. So now we should be living inside this container. Okay, and you'll see how this is going to work in just a second. The other thing that I'm going to do is we want to preemptively give these a place to live. We want to give whatever we're decoding back, we want to give it a spot to live in. So I'm going to say var ability names. Whoa. I can say var ability names is an array of strings. And right now we don't have anything in it. It's just an empty array. Okay. So there's this cool thing where containers have a property that is at end property where it will go through each thing, and then once it reaches the final item in the array, it can finish decoding. So what we're going to do here is we're going to say while the abilities container, and this will, yeah, there we go. While the abilities container dot is at end is equal to false. So like while it's still not at the final item, while it hasn't gone through the entire item set, because right here we only have 2 items that we're trying to access. So while it's at false, we want to do some work. We want to decode each of those aspects. This is how to do like a for-in loop to loop through all the JSON data that you're going to get. Kind of tricky. I'm actually going to rephrase this. And I'm not, instead of saying is equal to false, I'm just going to say while is at end is not. So while it isn't at end, that's what that bang operator is doing right there. It's saying while abilities container is not at end. That's what that's doing. So this is the same exact thing as saying equals false. They're the exact same. So just for ease of code, I'm going to do it like this. And I like that better. Okay. So this is where it gets a little dicey. And this is why I wanted to show you guys this, because it'll be some good practice for you. So this abilities array has multiple layers inside of it. So if you look, we get this array back. 0 is the first item, 1 is the second item. So we have one layer here, another layer here, and then if we're just trying to get the name out, we have another layer. So we kind of have to go a few more layers deep to get this name property. So it's not complicated. It just takes a little bit of know-how of how to dig into it a little bit more. So this abilities container that we've got has gotten us to this level right here. It's gotten us to an array of these 2 aspects. We've got the 0 and the 1. This is hopefully where we're living right now. And now what we want to do is we want to get into the abilities container, and then within the abilities container has a name. So I'll show you guys how I would go about doing this. I'm going to make a child keyring inside. So if you think about it, we've got a keyring like your car keys, and you might have 2 keys on it. It's like your car keys and your house keys. And then maybe you own a business and you have another keyring attached to it, and that keyring has specific keys for your building. So you might have your car keys and a house key on one ring, and then a keyring inside of it. I don't know if you guys can see me. Keyring inside of it has like 3 keys for your building. That's kind of the idea behind these child parent keys. So now I'm going to make an enum, and I'm going to call this ability name. Actually, because like you want to be descriptive of what's inside here. So I'm going to call this ability content keys. That's what I'm going to call it. You guys can call it what you'd like. That's what I'm going to call it. So just the same way, we're going to have it look for a string, and it's going to match up with these coding keys we've given it. Now, can anyone tell me what case that we're going to want to give here as the key, the name of the key?
Ability.
Ability. Yep. And how do you guys know that? How do you know that's the right one?
It's the next layer.
There you go. It's just this next line, right? Because we've gotten into this abilities array, and then we got a layer deeper. So now the first key that we're going into here is this ability. That's kind of what's happening right now. Okay. So if that's the case, we've got the ability key, but that'll open up another container. And now that container features the name and the URL. So we still have another child key. We still need to go a layer deeper into that now. So what I'm going to do is inside of this child, I'm going to make another child. This is like the grandchild keyring. I'm going to make an enum. And this one, I'm just going to call ability name keys. So now if everything goes well, we're living inside this container of name and URL. And all I really want out of this is just the name. So this is dicey stuff, but once you guys get practice doing it, you'll just see that we're shifting layers. We're just moving down layers every time a key is used. Okay, so while we're at this abilities container, we need to rifle through each of those layers, find the name of the ability, and tack it into this ability names array. This is one way to go about doing it. There are a lot of ways to do it. What I'm going to do is I'm going to say let ability, what did I call it? Content. I'm going to say ability content container. We're going to make a new container. And just like up here, we're just going to do try decoder. And then that specific, well, I don't know if I want to do, no, we're going to go into the abilities. This is why it gets hard, is because you forget which container you need to be in. So we're going to go into the abilities container, because that's the layer that we're working in here. This is the top layer, the next layer. Here's our third layer. So we're going to go abilities container, and then go into the nested container property. And what is the key that we want to use here? This is where you're going to see it's going to come in handy to name your enums a certain way. Think of the key rings. What is our coding key that we're trying to use?
Abilities, content keys.
Yep. So what we're going to do is we're going to say Pokemon keys. And then there's a key ring on our Pokemon key ring called ability content keys. And then we use that self property to self-reflect. I'm going to open this up a little bit more. Okay. And we don't really need a whole lot of this anymore, so I'll stretch it out. Okay, so we went one level deep. Now let's go one more level deeper. So what we're going to do is we're going to say let ability name container equal try. What's the container I'm going to try to get into now?
The ability container. Oh, I'm sorry. I named mine something different. The ability content container.
Yes. We're just moving layers down. Ability content container. So if you look, this is our top level JSON. This is all of our JSON. This abilities container is just what's inside of our abilities key. This guy right here. Sorry, it's kind of hard to like point out. And then one layer deeper than that is our specific ability. And now we just want the ability name. Okay. So what we're going to do here is we're going to do dot nested container. Whoops, I did unkeyed, but it needs to be keyed because it has a name. We're going to do nested container. And someone walk me through this now. What's the key ring we're trying to get into?
Ability name keys.
Yes. So we'll start at the top level. We'll go to our Pokemon, because you have to have your entire key ring if you want to start going through all the little smaller ones, right? So then we're going to go to our ability content keys. Then we're going to go to our ability name keys. Self-reflective, right? So now we've gone from this layer of keys to this layer of keys, and now we can hopefully just get the name out. And then the for key. Oh, I think I left this guy out, didn't I? Did I? I'm pretty sure I need keyed out ability. No, I think I'm good. Yeah, I'm good. Okay, so does anyone know what key we want to use here?
Dot name.
Dot name. Yep. Oops, sorry, not this one. Dot name. Because this guy's right here. So we just went through all of our key rings to find this one specific key. If you guys notice, we didn't have to use this case ability because all we needed to do was just have this key ring in order to get into this key ring. It's a child. Okay, what's the error I'm getting here? Ability name keys does have that. Oh no, that one did need it. That's why. I'm so sorry. So this one does need the for key property. And that's one's our dot ability. So it did need to use it. This should run now. And this is the beauty of working in a playground, is you're going to get to a point where things just aren't running like you want them to. Okay. So, and this will compile here in a second. If you guys have an error too, I think we're going to fix it here in just a second. So what we're going to do last is we're going to say, hey, if there is an ability name, we're going to try to get it out of our ability name container by decoding string under the key. I know why. I know what's wrong. Ha ha ha. This needs to be ability, and this needs to not have anything. This will compile now. That was the issue, guys. We were in the wrong key stack. So the error that I made is this ability content container. We're only just getting the keyring out of it. We don't actually need to get the ability aspect. And then inside the lower key level, we do need to use the name property. So if we get an ability out here, then it lets us move down to the next keyring of name, and then we can use this name property. So once we run the code and it decodes, you guys will see it, and then we'll talk through what each line of code is doing here in a second. So now we're going to say we have our ability name, hopefully, and then what we're going to do is we're going to take that ability names array, whoops, and I'm going to append the ability name onto it. Okay. So now that will throw that into our array, but there's still going to be an error here. Return from initializer without initializing all stored properties. Can anyone tell me how I can fix this error, or like why the error is happening?
You need to append to the array.
Well, we did that here, so that's good. But kind of the unique way we would have done. Sorry, Josh, go ahead.
Assign to the abilities in the original struct.
Yes, so this up here, we haven't initialized this abilities property. We have made an array of ability names, matches the same type, and hopefully has abilities inside of it. All we need to do is just say abilities is equal to our ability names. And then that error should go away. Cool. Now I'm going to run this now. And because we added this abilities property, we should be able to get all the specific abilities here in an array. It's going to make a network request. It's going to take its sweet time. Sorry, guys, we went a little bit over. And then once this is done running, I will walk through specifically what we did so that you guys can get kind of a better view of it. And that will be if our playground ever actually runs the code. Was anyone else able to hit run and have it pull up?
Yes.
Okay.
It loads.
So we did it right. It's just my slow computer. Is anyone having an error? Is anyone not getting back both a name and an array of ability strings? Everyone's good? Okay. All right. So let's talk through this a little bit because it can be dicey. And there's a reason that I chose this PokeAPI one, because it's hard. It's like a hard JSON to unnest. So first things first, in our Codable struct, you're going to want to input the properties that you want, to get out of it. For each property, you're going to want to make sure you check the JSON and you have a key set up to get that specific aspect out of it. So if I want the name, I need to make sure, for one, the type of my name is correct with a string, but I also need some sort of key to go in and get that item out of that key, that value out of that key. So that's what we did here with this PokeAPI. Your container has that property to decode them. And this is all new stuff to you guys, so this is going to be tricky, but it has this property and it asks for a specific enum. It asks for a set of keys so it can go and find the right one. So that's what we did here with this name. We gave it the right name. We gave it a place to live on the keyring. And then when I come down here and I give it what should be the whole JSON, right? This is like the container can be all the JSON information. And then if I want that specific name out of it, I'll actually retype this so that you guys can see it live. So I'm saying name equal try container. And then the container has a lot of properties inside of it. I think I moved through this kind of quickly, but it has a decode aspect where you can flash in a type and the key that you want it for. So this is where we just come back here and say like, okay, what's the type that we're expecting from the JSON? It's a string. And then where's the key that matches up the name of it in the JSON? So the key is nothing. And you could go through here and say like Pokemon keys dot name, and it would work just the same. The compiler is intuitive enough to know which name you're talking about because it's the top level one here. This name is a little different. We have to go rifle through the right set of keys to get it. Okay, and then this one is pretty tricky. Like this is a unique concept to look through and see how we like rifled through multiple items. But basically what's happening here is we're saying this is our big container. This is our container of just abilities right here. I used a nested unkeyed container because I don't have a name for these values. Like I don't have a name for this array that I'm getting back. If the JSON was configured in a way that said like abilities array, and that was the name for it in JSON, I could use just a nested container and it would have the name of abilities names. Like we could give it that name. This JSON is not configured in that way. It doesn't have a name. And that's generally what you're going to use for arrays. So like if nothing else, this is the way that you're going to use it when you get an array, when you're expecting an array back. These are generally the ways that you're going to expect to get a dictionary back, is these nested containers. So we gave it a container, and then there wasn't a really easy way to go about getting each specific ability name and then just throwing it into our abilities property. So we made a variable to be a placeholder for it. And then coming down here, we said, okay, go through all of the items that you're going to get back. So this 0 and 1. It might be a longer list in other JSONs, but go through 0 and 1 and go through each level. This is where it gets really dicey, right? So it's like, find the first container, go into the second container based off of this container. So what we were doing here is we're just saying, go from abilities into ability into name. So this code, I think when you guys refer back to it, it's going to be a great guide because this is as hard and as dicey as it gets. That's why I'm kind of glad that you guys got to see this one, because you're going to come back and the code sets and like JSONs that you're going to use going forward are not going to be nearly this dicey to work with. The Pokemon one is pretty nested, pretty heavy. So as long as we get in those right containers and we have keys to match up whatever's going into them, right? Because like, here's its ability key. As long as we're in the right container, we give it that key, it can go one level deeper. And then we can give it name as a key, and that will give us back this specific string. So all in all, in short, I think the way that we talked about in After Hours a couple weeks ago, not all of you might have been there, but it might feel like that was an easier way to do this. But this, in the long run, is going to save you a ton of grief and time to set up coding keys this way. It'll be much easier to refactor your code if you need to make changes if you set it up with keys, rather than having to make like 1,000 structs to go through. And the other cool thing, like Paul said, is we didn't do it in this example, but he took Luke Skywalker's height, and we were expecting it to get it back as a string, and he turned it into an integer. So it's just a great way to like be malleable with your code and change your types depending on what you want in your app. You don't have to be conformant to what the JSON is giving you. Okay, guys, that was some pretty heavy stuff. What questions do you have about coding keys?
The is at end, is that referring to the last value of the array? Or,
yep.
okay.
So it'll go through, so like in this one specifically, it said start with 0, go through 0, and then go through 1, and then the is@end says, okay, we finished. We're at the end of this. We don't need anything else. In a for loop, you use break. Like you guys have probably used break before to like end the for loop so it doesn't run infinitely. We're going to use is@end to break the while loop so it doesn't run for an infinite amount of times, if that makes sense.
Cool.
So
Thanks.
you guys will use this today in your afternoon project. Yeah, you're welcome. Okay, what other questions do you guys have?
I'm not clear how, so we do a while loop, and I understand the break, but I'm not clear how we're iterating it to the next.
So the iteration is happening just every time it goes through a specific item. And so that's why the keys help. So we say, while this container, this while loop goes through each aspect in that container. So our abilities container is all of this. So what we say is we just keep giving it layers to go into. And then the coding keys do the work of finding what's in that layer that we specify. So rather than having to loop through and get absolutely everything out of this, we can be really nitpicky about what we want. If we only wanted the URL, that's the beauty of using these containers, is that we can do that and not have to get all the rest of the information that's in that container.
If you guys remember how we had to like map the properties of abilities, or you had to like loop through them to get them all out, this actually flattens all of that data. So you don't have to loop through, like once we got abilities back, we had to loop through that. This makes it so you can get exactly what property you want in there, flattens all of your JSON, so you don't have to loop into these things and worry about drilling into kind of the nested structs. You can just get it all on the same level, just nice and clean and flat.
Yep. That's the beauty of coding keys. This is just a new thing that you guys haven't done yet. You've made structs within structs, right? Like we could totally make an ability struct that would follow a format similar to this, but it's not always like the best practice. So this tends to be the best practice to follow these coding keys methodology. And that way you give them a specific value, and if it's wrong, you can know really quickly why you're not getting something back. So if this still feels like, whoa, there's no way I could do this, that's fine, because I think when I started to do this, I felt the same. In the afternoon project, you're going to get some good practice doing it. So don't worry, you'll definitely get used to and good at using these coding keys going forward. All right, guys. Do we have any last minute questions before we close out for lunch? Okay. This is rough stuff. Like Codable is tricky because there's a lot to it. But just try to refer back to this and the Star Wars one, and it will help you kind of determine how to parse your JSON a little bit cleaner. So cool. My last recommendation is when you guys are making your key rings and you're making your containers, be really descriptive. You don't want to get lost in figuring out which is which. So that's why I kind of named these specifically. All right, guys, I will post this recording so that you can see it a little bit later if you want to refer back to it. I keep forgetting to post the last week's presentations, so I will post those as well, I promise. Cool. Okay, you guys are great. You're good to go to lunch, and I will post the link to the afternoon project. Be sure to take a full hour. Sorry for going over, but take a full hour for lunch, and then we'll get right into the afternoon project. Help desk will start at about 1 Pacific. Around 1 Pacific, we'll open help desk up if you need help. So good job, guys. I will see you back around in a couple hours. Thanks, everybody.